All right, good morning, class. Today we are going to start talking about the visible light spectrum, how it gives objects color. And we're going to start off talking about the primary colors. The primary colors of light are slightly different than what you would study in art class, which is the primary colors of pigments. Light primary colors are red, blue, and green. So how do you do this on your notes? Well, on your notes you have 3 overlapping circles. And what I would like you to do with those is to label them what color they are, or if you have colored pencils, you are welcome to take the time to kind of shade in each part of this colored light little Venn diagram that we have going on here. So if you notice down in the bottom right hand corner of the screen, you will see kind of a stable Venn diagram looking thing of the colors of light. You'll notice that since I told you the primary colors are red, blue, and green, you will see, I flip-flopped them. So what we're going to do is we are going to put green up here in this area. So you can either write the word green or color it green. We're going to put red in this area, and then we're going to put blue down here, which kind of changes up those middles. So your primary colors, again, will be green, red, and blue. So sorry for the mix-up. And then what happens is when the blue overlaps with the green, we get this color called cyan, which is kind of like a pretty aqua color, teal color, okay? And then in this overlap up top, where red and green come together, we get yellow. So go ahead and either label that yellow or color it in yellow. And then over here, if we have true blue and true red overlap, we get what's called a magenta color, which kind of looks like a pinky purple color. If you notice in the very center, when all the 3 primary colors overlap, it creates white light, which is what we see on a normal basis. So coming from bulbs, and we would see white light. But if that white light is refracted or bent, we see a spectrum of colors, and these are the colors that we would see coming from it. Okay, so first question underneath that diagram is what determines the color of objects? So the color of an object depends on the color of light that the object reflects. So therefore, if you have a red book, if you are looking at a book and it's red with some black lettering on it, that means that all of the other colors, the O, the Y, the G, the B, the V, are all absorbed and or transmitted, but in this case it would be absorbed by the book, except for red. Red is being reflected. Now, the part where you see the black lettering, that means that all colors would be absorbed there, okay? So we have all the colors of the spectrum coming from this white light. We don't get to see the colors normally unless it's being refracted or bent, but we have white light going towards the book, which is all the colors, and reflecting off the book to us is just the red color of the visible spectrum, okay? So you want to put what determines the color of objects. It is the color that is reflected towards our eyes from the object. Okay. Now, sometimes it can be a little tricky because you might have more than one color, and usually you would have more than one color of light being reflected towards your eye, because we don't always see things as true red or true blue or true green or true black or white. So let's talk about what happens if we see maybe purple pants. Well, to make purple, and you guys probably realize this from art class, you would have all the visible white light coming, and you would definitely have 3 colors reflecting off of it, because we know that the mixture of red and blue makes purple, but also there would be some violet reflected as well. So when there's colors that aren't the primary colors, it's a mixture of colors. That means that more than one wavelength of light is being reflected off of it. So on your paper it says, why is the color of Mrs. Harding's coffee mug red? Well, if it were true red, red would be reflecting off of it, but you also need to know that all of the other colors would be absorbed by it. The next question is, why is the color of Mrs. Harding's board white? Well, let's talk about this white hat down here. We've got all the visible light spectrum coming to it, so white light shining. And if the hat's white, if it's a true white color, that means that all of the colors of visible light are being reflected off of it. So if my board were to be a true white color, all of the visible light spectrum would be reflected off of it. None of it would be absorbed. None of it would be transmitted. All right. So let's move on to something else now. I think you're getting the hang of this. We are going to talk about filtered light. Okay. So the first thing you need to know is, what is a light filter? It is something that blocks out or absorbs different colors of light so that they don't reach the object. So you're gonna see that in class we will use a red filter at times. So basically it is a plastic piece that is red colored. And light can go through it, so it is a transparent object. And so when we shine white light onto it, we will only allow the red color to go through it. It blocks or absorbs all of the rest of the Roy G. Biv. Okay? If we were to use magenta, take this back to the pair of pants that you were talking about earlier in the notes, if we were to talk about magenta pants, then what would happen is you would have red, blue, and some violet coming through to make that magenta color, okay? Therefore, all the other light would be blocked by that magenta filter and would not reach the object. So when you're looking at your notes, we've already talked about what is a light filter, but now we need to talk about how does it work. And basically, that is part of explaining what a light filter is. It's a colored piece of transparent material that blocks out or absorbs certain light colors. That means that it allows sunlight to pass through it while the rest does not. So what happens when we use a filter and we're looking at objects? So if we have this pair of pants at the bottom, okay, and we have red light, so we're using a red filter, okay, to come through. We are going to see, that's not lined up very well, but his pants will not look blue to us. So if we're using a red filter, the red light only will be coming through. His shirt will still look red because the pigments in his shirt reflect red. But the pigments of his shorts are reflecting blue only. Well, if we're not shining blue light towards it, if we're only shining red light, that means it's going to absorb the red light because it normally absorbs red light and reflects blue. It's not going to reflect any color now because it's only going to reflect red light, which is the only color that is going towards it. So let's look at some more objects, and you'll see on your paper you have only room to do one object. So please don't do the red socks. Do one of the other ones that isn't completely filled in yet. And as a class, we will talk about your answers when we come back and kind of discuss how you did on these notes. So red socks, if we are shining it through a red filter, that means the red light will go through the filter. Well, if there are already socks that are red, that means they're reflecting red light and they're absorbing all other materials. So if we shine only red light on it, it will still be red. But if we take those red socks and we put a blue filter on the light where only blue light is coming through, those socks cannot reflect blue light. They're going to absorb it, which means that they appear black. Lastly, if we take those red socks and we shine green, which is the other primary color, towards it, and they will continue to look black because they absorb green. They don't reflect green due to the material and pigments that are in the material. And so therefore, the socks will appear black. Now, for blue teddy bear, I did do one for you, so if you want to continue blue teddy bear, or if you want to do the green camel or the magenta book, whichever one you decide to do is fine. We will review these in class. The blue teddy bear, if it is reflecting only blue light and we shine red light coming through that filter towards it, that blue teddy bear will appear to be black to us now. If we shine blue light, what do you think it'll be? If we shine green light, what do you think it'll be? All right, so we'll continue going over this in class. Thank you very much.